Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Afif bin Muhammad Faudzi. I'm from Faculty of Electrical and Electronic Engineering Technology, University Malaysia Pahang, UMP. My title is Region of Interest Detection in Thermal Image of DC Motor using Image Processing for Average Temperature Calculation, and my paper ID is 136. As an introduction, temperature measurement are very crucial for detecting equipment breakdown. Accurate measurement are very important for effective preventive maintenance that monitor the temperature variation and thereby preventing costly downtime and improving operational efficiency. In motor thermal modeling, calculations are needed to produce the convection thermal coefficient, and this coefficient require average temperature on the motor surface, which are conventionally measured using a thermocouple. Okay, that one is contact measurement, and there is a alternative, which is a non-contact method, which is thermal imaging technology. And using thermal imaging technology, there is one software, which is Test.ir software. And this software is widely used for thermal image analysis, but it has certain limitation. Okay, so the problem statement for my project or for my paper is the software selection tools are very limited because the tools is depend on geometries, limited geometry, which are oval, circle, rectangular, and others lah. And their size need to define manually by the user. So as for the objective for my project, first one is to detect the region of interest ROI using image processing, which we perform image segmentation, and the second objective is to compare the average temperature result between using the Test.ir software as to the image segmentation. As for the methodology, the motor that we use is 250 watt brush DC motor MY1016. The spec can be see on the table, and we only use the sample for this project, and the sample was captured by disassemble the armature and hang for the thermal image capture. And as for the overall process of our methodology, we can see in figure 1 and figure 3 the flowchart. Okay, first from the sample we load the data and image file. After that we convert the image of the thermal image to grayscale image, and then filter using Gaussian filter, and allocate the threshold value. We need to decide the threshold value, and then we count the total pixel of ROI. This one is in order to calculate the average temperature, and then apply the mask to the original image. Okay, the D is the binary threshold for the masking, and we only consider the one in the white area lah. Alright. Okay, and then we calculate the average temperature of the ROI region of interest, and as the final output we will display the output image and the average temperature value. Okay, so as we can see as the results on the left hand side, we compare between the method of IR software and then the result of segmentation method. Okay, on the top one is the sample number 3, and the bottom is the sample number 5. Okay, as we can see in the table, the average temperature of segmented ROI, or the one that we use the image segmentation, is higher than the one in using the IR software. Okay, and the average of the temperature difference is between 1.06% to 11.34%. As we can see, the value of image segmentation are higher. Okay, this one is because because we eliminate, okay, we eliminate the irrelevant area, so we only focus on the the, the important parts, okay, the important parts. So that's why the reading is higher than it seems. That is the best lah, the best, the better reading, compared to the one that we use a limited shape. Alright. Okay, so as the conclusion, the thermal image processing software RSoft has certain limitation. One of them is the shape of the selection tools. Selection tools are limited. Okay, these limited tools lead to inaccurate average temperature calculation because it's fixed, like circle or rectangular. Okay, then it will capture the irrelevant region. Okay, so this project overcome the drawback by performing image segmentation using thresholding method. As a result, the issue of the irrelevant region that affect the average temperature value of the region of interest was successfully eliminated, and a more accurate average temperature is obtained. Okay, so there's it can be improved, the result can be improved, and for the future plan, we are consider to make a better performance analysis. So instead of compare between software, we want to compare the data using the hardware itself. So using thermocouple. Alright, and another plan is we want to consider a better image segmentation, because in this project we only consider the color from the thermal image, and for the future we want to consider not only the color but also the shape of the object. Okay, because inside the motor there are different parts, and if we can consider the shape of the object, then we can get average temperature for particular that particular part. Okay, that's all for this project. Thank you very much, and thank you for listening.